Dividing radical expressions. You learned how to simplify radicals, how to multiply them. Now it's time, of course, to know how to divide them. Before we start though, there is a property that I want you to be aware of, and it is called the quotient property of square roots. So, the way this works is, we have this square root, or this radical. Inside the radical, we have a fraction. That is what we mean by quotient. So anytime you hear quotient, think fractions. So what it allows us to do is we can rewrite it in a way where you can detach, you can separate, however you want to think about it, but we can write it in this way. So instead of having the square root of a over b, we have the square root of a divided by the square root of b. Now this can be vice versa. So let's say we had the square root of a divided by the square root of b. We can rewrite it as the square root of a over b. But of course there's a catch. This only works if the index of these two radicals is the same. Otherwise, don't even try to do this. It will not work. So, one thing you might be asking yourself is how in the world can I divide radicals? You're probably thinking, I struggle dividing as it is. Now you want me to divide radicals? Well, I'm going to walk you through the process. So we're going to have this table here to help us. Anytime you have fractions, you got to think, okay, a fraction can be reduced. So use that to your advantage. First, you want to start off with, can it be reduced? Yes or no? If no, we move on to the next step. If yes, you need to reduce as much as possible. Next step, apply the property. If you need to, apply the property where you can split them up or put them together. Numerator and denominator is what I mean. So depending on what you say, then at the end, we want to simplify, which is our goal. So let's go ahead and start with this square root of 20 over 14. So like the chart said, can the ratio be reduced? Can this fraction be reduced? And the answer is yes. Both of those are even. They can be reduced by 2. So finally we get 10 over 7. So next step, do you need to apply the quotient property? Well, yes, we want to go ahead and split them up. Square root of 10 divided by square root of 7. Now, the thing with math is we don't like radicals as a denominator. Reason being is, when it comes to fractions, you want to think of the denominator as whole numbers. Think of pizzas. When you slice a pizza, you want equal parts, equal amounts, counting amounts of slices. Radical numbers here are irrational numbers, as in you're going to have a number with the repeating decimal, as in repeating numbers after the decimal. It never stops. It's not accurate. So, what we do to avoid having radicals in the denominator is we're going to multiply. Now this is a strategy. The top and bottom, numerator and denominator, by the radical that is in the denominator. So in this case, this is my denominator, so I multiply the top and bottom by that number. Okay, so we went over already multiplying square roots, and what we got is that we can write it in two ways. So instead of multiplying 10 times 7, I'm going to write it in like this, and instead of multiplying 7 times 7, I'm going to write it like this. So, concentrating on the numerator separately, 10 times 7. I want to factor the 10. So, 2 and 5. 7 cannot be factored, so I'm going to break it down. As you can see, none of these three factors can be paired up. So then that means that we cannot simplify 10 times 7. So I'm going to go ahead and write my answer as square root of 70. Okay. The denominator, however, the whole idea, the whole point to simplifying radicals, simplifying square roots was if you find pairs, pair them up. So here I have a pair of 7. So that would mean that the 7 goes outside of the square root only once, and there's nothing remaining. So really, I don't even need the square root. So it is safe to say that the square root of 49, because that's what I would get out of 7 times 7, is 7. I simplified as much as I could. Therefore, I can say that this is my final answer. Now you're probably thinking, okay, Ms., you said to simplify, reduce as much as possible. Can't we reduce 70 and 7? The answer is no. Do not divide 70 by 7, because it's not 70 divided by 7. It's square root of 70 divided by 7. Think of this square root as a house. The 70 is inside the house. This is not. So you cannot go inside the house and try to split it up. It doesn't work. So that is our final answer. Next one. Square root of 12 divided by 11. So the first thing we want to check is, can we reduce the fraction? The answer is no. So we go straight to, okay, apply the property if needed. And well, we need it. Now again, we don't want radicals in our denominator. So we're going to multiply by square root of 11, top and bottom. Okay. So again, instead of actually multiplying them, the product property of square roots allows us to just write it in this form. 12 times 11 divided by the square root of 11 times 11. So looking at the denominator first, quickly you can see, oh, there's a pair. So already in your mind you should think, okay, so then if that's a pair, the 11 goes outside, nothing goes inside the radical, so we don't need the radical. But now let's concentrate on the numerator. 12 times 11. So again, I'm not going to multiply 12 times 11 because that's going to be a really large number. So on the side, I'm going to go ahead and actually factor these out. So factors of 12, I'll use 4 and 3. Factors of 4, I can use 2 and 2. Factors of 11, well, 1 and 11, but we don't want those. So 11 is already as factored as it can be. So I'm going to bring it down to not forget it, bring down the 3 to not forget it. Remember, the whole purpose of simplifying radicals is to put them in groups. So in here, I'm going to pair them up. The 2 goes outside of the radical. And what did not get paired up, in case remember, they go inside the radical. So then I have a new denominator, which is not really new, it's just written in a different way. So now we have 2 square root of 33 divided by 11, and that is our final answer. Nothing else we can do with this fraction. Next one, square root of 18 divided by 3 square root of 24. So this one is going to be a little different. So what I'm going to do in this problem is I'm going to use the quotient property of square roots, but the vice versa way. So you understand that there is a fraction. You understand that there is a 3 outside of the radical. So I'm going to write my radical like this. I know, it looks a little weird. So what I'm trying to get you to see is that this part can be rewritten as 18 over 24. So that's what I'm going to go ahead and do here. 18 over 24. Now I'm writing it this way because again, I want you to understand that there is a 3 outside of the radical. So that is exactly how I'm writing it. But the 3 happens to be in the denominator. So it won't be so lonely. In my numerator, I'm going to write a 1. Now I'm going to concentrate on this 18 divided by 24. Go back to the chart. Start off with, can it be reduced? And the answer is yes. Square root of 18 over 24 can be reduced as 3 over 4. So what I'm going to do now is go use the quotient property of square roots and detach it. Go back to how it looked originally. So square root of 3 on top with 3 square root of 4 on the bottom. Now, we do not want radicals in the denominator. So what I'm going to do is, this number does not belong there. So I'm going to multiply top and bottom, numerator and denominator, by that radical. So as you can see, this is the same pattern of work being done over and over in every problem. 3 outside, square root of 4 times 4. Okay. Now, again, denominator, here's my pairs of 4s. So really, the denominator is 3. And 4 times 4, which is 16, square root of 16 is going to be 4. So I multiply those two. However, in my numerator, I have 3 times 4. If I break up the 4, I get factors of 2 and 2. And guess what? There's my pair. The 3, it's all loner. 3 stays inside the radical, and the 2 goes outside of the radical. So we have 2 square root of 3. Let me clean this up a little. And now we have 2 square root of 3 divided by 12. But before I say, okay, I'm finally done, I'm going to look at this part, at these whole numbers, and ask myself one more time. Can this be reduced? 2 divided by 12. And the answer is yes. They both can be divisible by 2. So we end up with 1 over 6. And do not forget the square root of 3 in the numerator. But of course, this 1 looks weird. We don't need it. Doesn't have to go there. And therefore, this would be our final answer. Pretty lengthy, yes. So let's go ahead and try another one. Now as we progress, I'm going to start cutting back on some steps because they're pretty repetitive. I'm going to start off by already thinking, okay, I'm going to split this up and concentrate on these whole numbers and think, can they be reduced? The answer is yes. 6 over 12 can be reduced to 1/2. So I'm going to rewrite it. I'm going to use the quotient property. Now there's no need to have that 1. There's no need to be so extra. So I'm going to remove it and split them up. Once again, we don't want radicals as a denominator. So we're going to multiply both top and bottom by the square root of 2. Okay. And then we get to multiply them. So I'll do that on the next step. In the numerator, 2 times y to the 5th would be 2 to y to the 5th. In the denominator, square root of 2 times square root of 2 would give us square root of 4. And square root of 4 is just 2 without the square root. So now we have this. What we're going to do next is we are done simplifying numerical values. What we're going to do is focus on this part, y to the 5th. So y to the 5th can be written like this. Y repeated 5 times. And then of course, since it's the square root, we pair them up. And remember, anything that did not get paired stays inside the radical. So the 2 and 1 of the y's. We had 2 pairs of y's, so I'm going to put y squared out here. And let's not forget the denominator of 2. And we're done. Simplified as much as possible. That is our final answer. Again, do not try to reduce 2 over 2. This 2 is inside a house. This 2 is not. Don't go in there messing things up. That's it. Next problem. Once again, ratio, fraction. In this problem here, we have the quotient property of square roots already applied. The only thing is, since we have a variable in our denominator, we need to state that that variable cannot be equal to 0. If it's equal to 0, 15 times 0 is 0, and we just cannot have a denominator of a 0. So what I'm going to do is, like the previous problem, I'm going to start off by writing it 35 and 15 inside the same radical, because they are the same radical. Okay, so I'm going to concentrate on the fraction 35 and 15 and ask myself, can that be reduced? Yes, it can. And we have 7 over 3. Don't forget w cubed is in denominator. So I'm going to apply the property once again and go back to how they were split up in the beginning. We don't want radicals in our denominator, so in this problem, I'm going to multiply top and bottom by 3w cubed. Okay? So again, I'm going to skip a few steps, and I'm already going to think, okay, 7 times 3, 21, w cubed. 21 cannot be broken down into factors that I can pair up, because the only factors are 7 and 3. However, the w cubed, that could be simplified. So when I expand, I notice, okay, there's a pair of w's that I can pull out. Everything remaining that did not get paired remains inside my radical. So I'm going to rewrite it. In my denominator, if you've seen the pattern from before, square root of 5 times square root of 5 is just 5. Square root of 13 times square root of 13 is just 13. So square root of x times square root of x, it would just be x. So with this same pattern, square root of 3w cubed times square root of 3w cubed, we're going to get that our denominator is just 3w cubed. Okay, but we're not done yet, because lo and behold, we have a w in the numerator, three w's in our denominator. That goes back to properties of exponents. When we have same bases that are dividing, guess what you can do to the exponents? We can subtract them. So when we subtract the exponents, we get w 1 minus 3, and that would give us a w to the negative 2. So this w to the negative 2 means that the w belongs in the denominator. A little confusing, I know. So what we're going to do is, this top w is gone. It reduced with one of the w's here. So instead of having 3, now we're down to 2. So now our final answer is square root of 21 w with the 3w squared. And you see what I mean? That goes in my denominator. This is our final answer, simplified as much as possible. And last example. So quickly, again, cut down on steps. 80 and 20 can be reduced, but guess what? Here I can use the properties of exponents again. I can subtract those powers. So I'm going to rewrite this. So we actually end up with no more fractions. 80 divided by 20 was 4. K to the 9 divided by k to the 4, subtract the powers, and we get k to the 5th. So we can easily simplify. Square 4 can be broken into 2 and 2. K to the 5th, we got 5 k's. Pair what you can. These are alike, these are alike, these are alike. What did not get paired? This k out here. Oop. What did get paired? Well, we had 2 pairs of k's, and we had 1 pair of 2. So my final answer is 2k squared, square root of k. And we are done.